Okay, we're going to talk about how we get people out of a building. This is known as the means of egress. Now, you might be looking at this going, wait a minute, we're in chapter 6. Why does that say chapter 7? This is from a previous book that I used to use. I just think it's a better PowerPoint, so ignore that. This is chapter 6 in our book, Means of Egress. Martin Luther King was quite a great man, and he had a great attitude on work. He said, if a man is called to be a street sweeper, now you might think street sweeper. Well, before there were vehicles that did street sweeping, one of the worst paying jobs in a town was to be the person that would go out and sweep the streets. It was considered even to be lower than, some people think the lowest paying job or the lowest job in a business is being the janitor or the custodian, person that cleans up the bathrooms. Well, back in the day that he said this, street sweeper was as low as that, if not lower. So he's saying if you've got the worst job in town, if a man is called to be a street sweeper, he should sweep streets even as Michelangelo painted, or Beethoven composed music, or Shakespeare wrote poetry. He should sweep streets so well that all the hosts of heaven and earth will pause to say, here lived a great street sweeper who did his job well. I think that's a great quote. Do your best at everything you do, no matter what you do. Always do your best. Today we're going to talk about means of egress. We're going to talk about the 3 different parts of a means of egress system. We're going to talk about we're going to define some words like common path of travel, dead ends, design occupant load, horizontal exits, travel distance. We're going to talk about what's the difference between a gross floor area and a net floor area. And, I'm sure you're familiar with these terms because you have your gross pay and your net pay when you get your paycheck. And it's always way bigger of a difference than I would like. Uncle Sam takes a lot of money away from us. We're also going to talk about the 6 steps that we use to design a means of egress system. Let's make sure that we get people out in a safe manner. We want to create the system for everyday use, but also for worst case scenario. When there's an earthquake, when there's a fire, or some kind of an emergency, how do we get everybody out safely? We have 3 important terms you want to pay attention to and understand for this chapter: use, occupancy type, and occupancy load. Use is obviously what the building is used for. It's the answer to the question, what are you going to do there? This is very important for fire prevention. Every building is the height of it, the width of it, the kind of materials that are used. Everything is based on what are you going to be doing in there. Are you going to live there? Are you going to make stuff there? Are you going to store hazardous materials? All of that matters. So use is a very, very important question we need to ask each person. Well, based on what they say, the use is going to be, the code has put people into categories, and we call that occupancy type. So occupancy type is the category that the code puts this building in based on what you're going to use it for. What's the use? Now, occupancy load is an extension of both of those terms. Occupancy load is the amount of people we're going to allow in each room or in the building as a whole based on that use. So when we design a means of egress system, one of the first things we need to know is what's the occupant load? How many people are going to be there? Based on how many people are going to be there, then we're going to figure out how many exits do we have to have. How far can a person go from their station where they work? Maybe it's a desk, maybe it's a lathe, maybe it's a drill press, whatever it might be, from where they are to where they get to an exit. We call that maximum travel distance. Exit remoteness. Are we going to allow all the doors to be right next to each other, or do we need to have them spaced throughout the building? And minimum ratings for enclosures. All of these things are going to be a part of the means of egress. So there's a lot of code provisions in this that, as we establish this means of egress, that are going to now say, well, what's the size of the door? What way does it swing? Does it swing out or does it swing in? There are situations where we do want doors to swing in. The hallway there at the school, the doors for the hallway, they swing in because we don't want to smack somebody walking down the hallway with, opening a door to exit the classroom. But notice that the doors that go directly outside, they all open out so that it's easier to exit in an emergency. The locks and the way they latch, the lighting, we have to have exit signs, adequate identification. All of these are provisions in the code. So let's get right to it. The three parts of a means of egress system are exit access, exit discharge. Now those are the three parts, but there is a fourth definition we need to understand. Every exiting system ends at the public way, and we'll define that in a second. So what's the exit access? Well, it's every portion of that means of egress system that's not in the exit. So it leads from any occupied portion of the building or room or structure to an exit. So the exit access extends from a student's desk in the room until they get to an exit door, an exterior door, or, as we're going to see in the definition of exit, a dedicated rated enclosure that leads to an exterior door or to a horizontal exit. So basically, if you're not in the exit, you're in the exit access. If you're in the building and you're not in a portion of the building that's considered exit, you're in the exit access if you're not in that. Okay, so we'll understand that a second when we define exit better. So here's a picture example. This is at my church. This is where we sat, for these meetings. And the exit access will be the area where all the stuff happens. That's a good way to think of it. If the purpose of the building is for meetings like this one, well, this is where we meet. If the purpose of the building is to make stuff, the exit access is where they make the stuff. So exit access is all of that portion of the building that is not considered part of the exit. So the office, the meeting room, the factory floor, all of that. So very important that we understand then, well, what's then the exit? It's that portion of the means of egress system that could be just an exterior door. It also has to be separated from interior spaces of the building with fire resistance rated construction. So once you're in the exit, here's a very, very important term. Once you're in the exit, you're protected. So, fire-resistant rated walls. Opening protectives, fire-rated windows, fire-rated doors. These are all portions of or components of the exit that provide a protected path of egress travel. So if you go from a classroom into a hallway, it's not necessarily fire rated. But if it's fire rated, you're going to have doors that have very small windows, and those doors have windows that are fire rated, so they'll have a little wire in them. The door will be thicker because it's going to slow down the spread of fire. All of the walls will be double the amount of drywall so that the fire goes slower through those walls. So once you're in the exit, you're protected. So an exit may only be the thickness of an exterior door, or if you are in a protected hallway or a protected corridor, it could be an unlimited distance. So in the exit access, we're going to talk about in a second, you have a maximum travel distance. You have to be within a certain amount of feet from the exit. But once you're in the exit, we're making it in such a way that you're protected, so it can be an unlimited distance. So you can have a stair tower that's 27 floors high. But once you're in there, all the doors are fire-rated doors, all the walls are fire-rated walls, and maybe we're even going to use smoke evacuation, or we're going to positive pressure the stair tower so that you have clean air in there. You're protected. So another example is the big long exit passages in a mall. Any of you who have worked at a store in the mall know that on the backside of each store, there's these big, huge passages, and part of that is for your deliveries, but it's also your exit path out of the mall. So exit enclosures, exit passageways, exterior exit stairs, all of these are part of the exit system. Exterior exit ramps and horizontal exits. So let me show you some examples. This again is at my church. So this stairwell from the second floor, that door that you see on the right is the fire-rated door. See the wires in the window? And this is an automatic closing door. And so once you go into that stairwell, you are protected. And this on the left is a picture of that stairwell. And there's rules that apply to the railings, to the size of each stair, the rise and tread, where you however a certain amount of feet you have to have a little landing. See, there's a landing in the middle, and all of this is per the code, and you're in a protected portion of the building. Well, what about when you get to the bottom of the stairs? When you get to the bottom of the stairs, it exits into this corridor. And this corridor is also fire rated. Every one of the doors that enters into this corridor is a fire rated door. The walls are thicker. And as I mentioned with the stairs, this has got a little bit of a ramp. So because there is an elevation change, there has to be railings. And that ramp can only go down 1 inch per 12 inches out, 1 inch down. 12 inches out, 1 inch down. And so that's because of wheelchairs. We don't want anybody, getting on here in a wheelchair and then zoom, they're all the way down at the bottom. And we don't want that to happen. So also when you're in the exit, we got to make sure that there's proper exit signage to identify where the exit is so that you follow it out, and you can see that in the bottom right picture. Well, then where do you end up? Well, you end up in some kind of a lobby, possibly like the one in the top left, but you're going to eventually get to exterior exit doors. And these are, of course, because this is a big place, this is a big church, they're going to have panic hardware. They're going to open out, and they're going to be automatic closing. Notice all the exit signage, and there's exit signs above and below. Because this is an assembly, they require that there be exit signs where people might be trying to crawl out because of smoke. They want an exit sign down low as well as up above. And that is all the components, or can be the components, of an exit system. Now, there's another kind of exit. It's called a horizontal exit. And a horizontal exit is when you go from one building to an area in another building. But if you do go into a horizontal exit, you've still got to be protected. It's got to be approximately the same level. And sometimes this is through or around a partition to an area on the same level in the same building. So sometimes buildings are, like especially factories, they might be so big that they make it's one building, but they put a wall in the middle to make it like it's two buildings. And that wall in the middle will have fire-rated doors, and usually these are the sliding kind that have a fusible link, and that melts when there's fire, and then there's a weight that pulls the door closed and makes it so the fire won't go from one part of the building to the other part. But it's still part of the exit system, and if you go horizontally from one building into the next, they call that a horizontal exit, and now you use that exiting system to get out. There are also some where you actually go from one building to another building, and the only example I know of that is the Kodak Theater that became Cirque du Soleil and now has a new name. I don't know what it's called, but it's down in Hollywood. And you go from the theater into it's a horizontal exit. It's a passageway that goes from one building, and at the second level, it goes into the mall next door. And you enter into that mall's exiting system, and you get out of the building that way. You have to be safe from fire and smoke if you're in a horizontal exit. Lastly, we have the exit discharge. Once you get outside of the building, you're in the exit discharge, but you're not necessarily safe yet unless you're at the public way, which we're going to explain that in just a second. So sometimes you come out of a building and you're still in a gated enclosure of some kind. So you can see this in the picture that people are exiting out of a door into a sidewalk, but you're not necessarily safely away from the building yet. So can you have gates? And if so, under what kind of conditions? If you have to walk along the building before you get to the public way where you're considered safe, then you're in the exit discharge. So some buildings exit straight to the public way, so they don't have an exit discharge, but most have just, sometimes it's only, 10 feet of sidewalk or whatever. Let me show you another picture that's a real good example. And this is where my daughter works, Sunshine Daycare. And if you notice on the left, there's a door, and you can kind of see that there's a door that enters onto this on the right-hand side where that chair is in the picture. So people exit into this courtyard that's in between the buildings, but they're still not safely away from the buildings. So this is a portion of the exit discharge. Then they exit towards that gate. Now that gate has to be the kind of gate that opens with a single action, and they open it. There should be panic hardware on there. I tried to talk them into adding panic hardware. But you push it, it opens, and now you're out in the parking lot, and that is considered safe. So when you're safe, we consider that the public way. And by definition, the public way is a street alley or other opening to outside air leading to a street. So basically, it's considered permanently appropriated for public use. If it's clear width and height of not less than 10 feet, then we consider that the public way for public use. All of those parts there have to go together to make it the public way. So here's a little, corny little drawing that shows you the three means of the parts of egress. When you're in the building, doing what you do in the building, you're in the exit access. You have to be able to get to an exit within a certain amount of feet. We call that maximum travel distance. We'll define that in a minute. But you go to a doorway that leads you to the exit. Now, that doorway might lead right outside and you're at the public way. Boom, you're done. But sometimes it's something more intricate and complicated, like the example of a stairwell here. As long as you're in the stairwell, you are considered to be protected, and the fire will be delayed by the way the building is built. So the exit is a protected way. Then once you leave the building, if you aren't yet at the public way, then there will be a portion called the exit discharge, and you go through that portion of the building to the parking lot or to the street, and then you're considered at the public way. Well, when we design these systems, the first thing we have to do is we got to figure out how many people can be in this building. That's called the design occupant load. So how do we do that? Well, again, we got to ask the question, what are you going to do there? And so design occupant load equals how many people can be in a room. And the formula for figuring that out is to, first of all, you've got to find the area of the room. Well, oh my gosh, this is math. I'm sorry, you got to go back and do some math. How do we figure out area? Length times width. Yep. What if it's a circle? Pi r squared or something like that. So you divide then that area by a factor that you're going to find in a table in Chapter 10 of the building code and the fire code. It's the same in both of them. So you find the table, and based on what they're going to do there, we're going to find a factor in this table. And so we're going to divide the area of the room by that factor. That's the answer to the question, what are you going to do there? Now, this is one of those places where you got to be careful. You're not going to use the occupancy type like we learned about. You're going to use the answer to the question, what are you going to do there? Because within an assembly, there's a lot of different ways, or a lot of different uses, a lot of different ways we're going to use the room. So we're going to divide it by whatever you're doing in that area. So that leads us to, there's two kinds of factors. First of all, there's gross floor area. So in some places, like factories, we're just going to take all of the building. So the well, this is not a good example because that's an assembly. Let's say it's a factory. We'll factor in the closets, the bathrooms, all areas of the building. And that's the gross, the total of the room. And we're going to divide the area by the factor that the code tells us. So it might be 20 or it might be 100. So if we have 4,000 square foot building that's for a factory, it's industrial use, the factor is 100. We divide 4,000 by 100. We can have 40 people working in that area. Net floor area is in situations like this drawing on the left. A ballroom that has a coat closet, it has chair storage, but we might dine there, but we also might dance there. We also might watch a concert there. There's all of these different kinds of uses. So with that, we're only going to divide that part of the room that's being used for a particular use. So the dancing area, we'll figure out what that is. The dining area, we'll figure out what that is. Then all uses are calculated. We'll get a total for the building, but we'll also give a total for each area. And then if there are multiple uses, we're going to post them all with an assembly. We require that they put the amount of people allowed in the room on a wall on a sign. So here's an example of that. This is the Club Nokia. I think it has a different name now also. This little room has 4 different load factors. If you look at the top part of the picture, there's fixed seating. And now that's figured by chair. We're not going to get into that. But if they were booths like in a restaurant, we would figure out based on 24 inches per butt. So 24 inches per person, but you know, it's really what we're talking about is their behinds. Now some behinds are bigger than others, but they've given the number 24 inches if you're dining there. If you're like in a pew at church, it's 18 inches because you're not going to be throwing elbows around like when you're eating. But that's for fixed seating. So that's in the top portion of the building in that balcony. But now look down below, we have a standing area that's up front. You see that? That's not the stage. That is a standing area or dancing area. So if they're just standing or dancing, we're going to give them 5 square feet per person. So we're going to figure out that area and divide it by 5, and that's how many people can be in that part of the building. The sitting area, if you notice that goldish looking thing, those are chairs, and their factor is 7. If you're just sitting, not dining, no tables, just chairs, then we divide that area by 7. And then lastly, in the background, you can see there's a bar there with chairs, and also there's some high boys. So that's kind of a dining area, and we're going to figure that at 15 square feet per person. So we divide the area of that portion of the building by 15. I know this is a little confusing, but you're going to do a little project on this that'll help you kind of move along with understanding it. And please, please email me or leave me a message if you're having trouble with that project. So again, we see that the design occupant load factors, these are all from the code. 5 per square foot, 7 per square foot for concentrated seating, 15 per square foot for tables and chairs, 30 per square foot for mercantile areas, 100 per square foot for business areas, and 100 per square foot for industrial areas. There's a lot more in this table, and you need to download that. You'll see it in your project. Then, once we figure out how many people are going to be in the room or in the building, then we figure out how many exits. So the code tells us there are certain exceptions where one exit is allowed. These are kind of rare, small offices and things of that sort. Basically, if you have 50 or more people, you're going to be required to have 2 exits. But sometimes even when you have less than 50 people, there is requirement to have 2 exits. So it just depends. That's kind of a complicated thing, so we're not going to get into it. But for our purposes, if you have up to 500 people, we're going to require 2 exits. If you have a 501 to 1,000, we're going to require 3 exits. And then once you get over 1,000, 4 exits. Well, guess what? That's the last one. Now, wait a minute. What about a theater or a concert hall that holds 8,000 people? You're telling me that 4 exits is enough? There's another little complicated part to this that we will figure out and show that we're going to require more exits based on the amount of people. So after we figure out how many exits, we're going to figure out the exit remoteness. Now that's done with math again. Oh no, I hate math. But this one's not too hard. The exit remoteness, the code says that the exits have to be spread apart by figuring out half the longest diagonal. So you go from one corner of the room to the opposite corner. You measure that. Now you can figure that out with math because it's a right triangle. And the next slide shows you how to do that. And I look at it and I still don't understand. But I'm not good with math. But the diagonal from one corner to the other in this example is 50 feet. So half of that is 25 feet. So the code is telling us that the exit doors have to be a minimum of 25 feet apart. That way, half of the room can go out one side of the building and half can go out another side. So, yeah, this is saying 100 times 130 is the restaurant. 100 squared plus 130 squared gives you the overall diagonal dimension. I don't know. This confuses me. And then there's a square root thing in there too. So maybe you understand this. I'm just going to measure from one corner to the next corner, half that. Now, if it's non-sprinklered, it's one thing. But if it's sprinklered, we're going to let them be a little bit closer. But, you know, you can figure that out. I just do it the old-fashioned way. I measure from one corner to the next corner, and half of that, the door's got to be at least that distance apart. Well, what about maximum travel distance? When you are in the exit access, you have to be within a certain distance from an exit door. Now, if it's a sprinklered building, it's going to be a different distance than non-sprinklered. And high hazard uses we're going to make sure that you're even closer to the exit. So generally, it's 150 to 200 feet for a non-sprinklered building, 200 to 300 feet for a sprinklered. Now, we've been looking at a building that was an assembly. So it's non-sprinklered, but you know, these days most of them would be sprinklered. But let's say it was non-sprinklered. It's 150 feet. So from anywhere in the building, when you're sitting at your desk or you're sitting at your table in a restaurant, you have to be, according to the path of travel, not as a crow flies, 150 feet from an exit. So it's got to be the common path of travel traversed before two separate and distinct paths. So you got to travel to two exits are available. So look at this example here. In the green, you're in the exit access. So from the most remote office, you can pick this one or the one on the far right in the back. How far is it to an exit door? And you have to have, if two exits are required, you have to have two optional ways to go. And we're going to figure it out in the common path of travel as those green lines go. And then once you get in the exit, once you get in the exit, now travel distance doesn't matter because you're protected. So it can be 1,000 feet, it can be 25 floors of stairs. You are protected, so it's going to be an unlimited distance. Now, once we've figured out the design occupant load, how many exits is minimum? This is the minimum number of exits. We've spread them apart, and we figured out the travel distance. Now we got to figure out the exit capacity. We got to make sure that the hallways are wide enough. The aisles, where you're sitting, you don't want to be sitting, where you can't stand up and get out. I hate when I got to go to the restroom and I'm at a movie theater and you got to stand and walk out and step on everybody's toes as you're trying to get out. It's really embarrassing. But we want to make sure that that distance between the front of a chair and the back of a chair is enough for people to get in and out, especially in a panic. Then the aisles, then the hallways, and until we get to the public way, it's got to get bigger as more people get in it. So we want to make sure that the capacity is big enough. So the doors, the ramps, the corridors, the passageways, everything is going to be based on that old occupant load factor of the amount of people. So the code says minimum 50 people or less, we've got to have 36 inches for corridors, passages, ramps, and stairs. If it's 50 people or more, a minimum of 44 inches. The doors have to have a minimum width of 32 inches, and we're not talking from frame to frame. We're talking from the door to the other frame. So it's a clear, unobstructed width. And here's an example of that. The door to the frame has to be 32 inches. The door leaf from frame to frame is 36. That's a minimum. Well, how are we going to make sure that it's enough? Well, if our design occupant load is 680 people, we're going to times that by 0.2. That equals 136 inches. If you, in a 680, how many exits are required? It's 3, all right? So we have 136 divided by 3. That means that the exit's got to be at least 45.33 inches wide, those 3 exits. So all exits have a minimum opening of 32 inches. Since this is an assembly occupancy, the main exits must be able to handle half of the occupant load. So we're going to put half of them in one place and then the others in another. But we're required to have 45-inch doors or more doors. So the minimum clear space for the exit is 32 inches. If I divide that by my capacity factor, I'll find out how many occupants each door can handle. So 32 divided by 0.2, 160 people. The code says we need a minimum of 3 exits with a minimum of 32 inches clear width. Will that handle 680 people? No. So what needs to be done? Front exit needs to be able to accommodate at least half. That's 340 people. 68 inches divided by 0.2 equals 340. Other doors are going to have to be larger than 32 inches. Now, it talks about that if there's a sprinkler system, the factor's 0.15. But the bottom line is when we divide everything by 0.2, we find that those 3 doors aren't enough. So if we have that 4,000 person assembly, rave place or nightclub, whatever, we're going to divide the number by 0.2 and we're going to find, 4 doors for over 1,000 is what's the minimum required, but we're going to have more to handle this amount of people. Lastly, the last step, we're going to make sure that ensure that we have minimum sizes. So we're going to look through the whole process. 50 persons or less with corridors, as we said before, is 36 inches. 50 or more, minimum of 44 inches. And but as more and more people dive into the system, you're going to find, so if you've gone to the Staples Center, you're at your seat watching the game. Now, you know, most of us can only afford the nosebleed section up in the top, and our seats are as close as can be because they want to get as many people in there as possible, but it has to be a certain distance based on the code. We get up to go, then we go down our little row to the aisle. Now the aisle is wider than our little row space was because more people are getting into it. As we go from that aisle down to the exit tunnel, it's wider because people are coming from different aisles into it. As we go from that tunnel into the main exit outside of the arena, we'll find that that's huge now because tons of tunnels are emptying. As more people come in, it gets wider and wider and wider. It can only get wider, never smaller. Now, there's a lot of special requirements. The main exits from assembly buildings have to be able to handle a certain amount, half. What about if we have revolving doors? Well, there has to be an equal-sized door next to it that's a normal door. The locks and the latches, there's all sorts of special requirements on those. It has to be single action. It cannot be can't have a deadlock, except there is an exception that if it is an assembly, they can put locks on it, but if they do that, they have to have that sign above the doors that says these two doors to remain unlocked during business hours. We're also going to require that they identify this whole means of egress system. We've got to have exit signs, and the code says you have to be within 100 feet from a visible exit sign at all times. And they have to be illuminated. So here's an exit sign you can see here that also serves as the other part. We got to make sure that the egress system is illuminated. So what if the power goes out? We're going to have battery backup or generator backup in the exit access and in the exit and in the exit discharge. We've got to have adequate lighting so that people can see. Have you ever tried to go downstairs in the dark? You know, it's not fun. So there's got to be proper illumination, and so you see those bug eyes in both of the pictures. Those are going to turn on if we lose power in a fire. So then they require that you assess the mean of egress now backwards. So you're going to look at the system once you've built it, and do the whole thing again and check all your numbers, make sure that you've done it adequately. So our steps in assessing the means of egress, we want to find out how many exits, are they adequately remote, is the travel distance acceptable, what is the capacity, how does the net floor area compare with the use, and are the exits all conforming? So how many exits or exit access doors are available? Are they properly remote, half the distance? Have we made sure that everybody in that room is within the minimum or maximum travel distance? No more. Have we made sure that the hallways, the aisles, all of that meets that those numbers of 0.2 or 0.15 if it's sprinklered. And we want to double check our occupant load that we figured out. Is all our math good on that? Do the exit components conform? All the locks single action? Do they latch properly? Are they automatic closing if that's required? Are they fire-rated doors if that's required? Do we have our exit signs? Do we have proper illumination? If we are satisfied with all of that, then we're done. So, in summary, we've got our three parts: exit access, exit discharge. Occupants cannot be exposed to a greater level of danger during egress. They've got to be protected. Once they hit the exit, they're protected the whole way. Travel distance is regulated to minimize the time that they are exposed to fire. So they have to be within a certain distance of an exit. Exits, this is really important, can't serve any other purpose. You can't put your storage in the hallway. And exit discharge sometimes is one of those things that's overlooked. We got to make sure that once you're outside, you're at the public way. If you aren't, we need to make sure that people are still safe while they get to the public way. The last thing we want is get everybody out of the building and then find that they're trapped in a fenced-in area that's locked and they can't get away from the building. And in case of an earthquake, now the building's collapsing on them and we've got, people that are all mush, because they're scrunched. So that'd be gross. We don't want that. We want everybody to get out safely. And lastly, all portions of the means of egress system have to be illuminated. So where did it all start? It started with the design occupant load. You're going to figure that out in our project, the design occupant load, for a whole bunch of different scenarios. Just take the time to look through it. Feel free to call one of your friends and do this together. I don't want you cheating, but I want you helping each other. So email each other, call each other, whatever you want to do. And if you have any problems, email me, and I'll help you out with it and explain it, okay? Now, one last thing. Illegal changes in use is something we are looking for when we do inspections, because it changes the whole egress component system. So that's why we need to understand occupancy type when we go out and do inspections. Okay, I got this one in way under an hour. Sorry for the long ones that you have had, but this one is done. Thank you.